Uh, Hello everyone. So welcome to the fifth live session for the course Earth Sciences for Civil Engineering Part 1 and 2, which is taken by Professor Javedin Malik from Department of Earth Sciences, IIT Kanpur, and myself Ananya Mukherjee, and I'll be taking this live session. So till now we have seen the different components which make up the earth, the rocks, minerals, okay, and then we saw the kind of geological structures, major structures that we see on the earth's surface, and how they are formed, how they are classified, how can you identify these geological structures on field. Okay, so after learning these were the basics. Okay, so now we would like to know how these affect, the construction sites that you would want to choose, and how any of these processes, any of the movements that are happening, large scale movements that are happening, on the earth's surface, how are they going to affect your property, and how you can utilize the understanding of these processes and movements and their effects, and kind of design your civil engineering projects. So today we will talk about natural hazards. Okay, so what is a hazard? A hazard is, when you talk about hazard is something that can cause negative impacts on something. So when we are talking about natural hazards, they are usually environmental phenomena that have the potential to impact the society's life, property, and environment as a whole. So there are natural hazards and then there are man-made hazards. Okay, so natural hazards are usually that are caused due to natural processes that are happening across the earth's surface. So example, floods related to the changes of the river flow, changes in the quantity of the water that is flowing in a river. You might have heard about the flood banks that are there next to the rivers. These are the banks which usually they experience flooding when the water level in the rivers rise, and then they flood the area adjoining the river. But if the floods are caused due to a dam failure, so that would be a man-made hazard, because dam is not a natural, obviously it's not a natural feature, it's a man-made feature. So if a flood, that floods is a natural hazard, but if the floods are caused due to man-made structures or due to man-made faults, then it would be described as man-made hazards. So now when we know what are natural hazards, now there is another term that is called natural disaster. Okay, so these are sometimes used synonymously, but they are different from the fact that hazard is the threat that is there, okay, of an event, and the possibility of it causing a negative impact. Okay, the negative impact of it, the potential of it causing the negative impact that we are talking about, that would result into a disaster. Okay, so a natural disaster is the negative impact following an actual occurrence of natural hazard. uh, there are very small seismic events that are happening across the globe at certain places every day. Okay, but not all of these seismic events are going to turn into a natural disaster. Okay, seismic event is a hazard, it can cause a disaster. Okay, so this is the basic difference when we are talking about natural hazards and disaster. And a natural hazard can be caused, okay, and the disaster can sometimes be prevented. Okay, the disaster, when it happens, it will significantly harm the community and the society around that area, and sometimes the people can cope up with it very easily, sometimes they cannot cope up. Okay, so the extremity of the disaster also depends on how well prepared the government or the institutions over there, or of the affected area is. Now we move on to types of hazards. So we have two. One is atmospheric or meteorological hazards, and the other is the geological hazards. Meteorological hazards are usually associated with processes that are related to the atmosphere and weather related hazards. So some of the examples are mentioned over here, like cyclones, hurricanes, heat waves. Then you have droughts, then hailstorms. Hailstorms are, snow and ice, severe storms containing snow, ice and wind. Then you have dust storms. So these are some examples of the meteorological hazards. Now geological hazards are usually happening due to the movement of, say plate boundaries, tectonic plates, or seismic events happening within the tectonic plates that we have talked about in previous classes. So you have earthquakes. Earthquakes usually happen when two plate boundaries are moving past each other, or towards each other or away from each other. Then volcanoes are also they cause seismic events. Seismic events means ground shaking. Okay, any of the processes that is going to cause the ground to shake, that would be a seismic event. Then landslides. Sometimes landslides are also weather related, but sometimes are also related to seismic events. Then you have tsunamis. These could be caused. This is mostly caused due to the earthquakes that are occurring within deep ocean floors. Okay, and then you have floods. So floods can be related to weather, heavy rainfall. One of the reasons of the floods could be that, and floods can also be caused due to some geological processes, like we will see later on in the lecture. So we are talking about natural hazards, and we are saying that they are naturally occurring processes. Okay, but when these processes happened, previously, human interaction or human interference were not very much counted in consideration. Previously, because we had less population, and the interference was not much. But in the recent years, as we know, that due to some of human activities, the land the in the threat of natural hazards turning into natural disasters is increasing. So one of the reasons that is happening is due to the changes in the land use patterns. Land use patterns, like when you have urban development, so we are kind of cutting down trees, and we are constructing roads, parking lots, buildings, and such structures, and this is going to make the surfaces impervious. Impervious means that it cannot hold water anymore. The water, suppose you have heavy rainfall, okay, but since our surfaces are impervious right now, so the water is not absorbed by the ground, and what it results into is, as we often hear, waterlogging we see in urban areas. Okay, so that is one cause. Then deforestation, obviously, it causes soil erosion, and which inadvertently causes your landslides, and you have floods. Then you have agricultural land use also. It kind of depletes the native habitats, and it will increase erosion as well again. And then you have one of the significant causes of getting affected by, say, tsunamis or tidal events, is loss of mangroves along the coastlines. So these are some of the human interferences that affect the natural hazards, and the threat increases. Then this also, as we said before, also waterlogging and such issues are also caused due to poor urban planning. Sometimes low quality construction materials. So suppose even a very low magnitude earthquake could cause destruction in the buildings and such construction properties. So now we would like to know why studying the natural hazards is so important. because natural hazards, as I have said before, it can convert into a natural disaster, which affects like the entire spectrum of our life. Like we have loss of life, we have destruction of properties, migration of population, because suppose there is an area which is constantly hit by such natural hazards, and the population over there cannot handle the after effects of it, so it will encourage them to migrate from that place to another place. And obviously disruption of economic activity, and you will have to rehabilitate people, you have to recover from that, you have to reconstruct things. So these are some of the major effects of natural hazards, the physical effects. Okay, so as you can see the figure to the right on top. Okay, so the figure here, this is actually from the Bhuj earthquake that occurred in 2001 in Gujarat. So you can see that there is a lot of damage to the buildings around here, and obviously it caused a lot of loss of life over there. Then over below here we see the after effects of the Kedarnath flood that happened in 2013. So this was the normal level in March, and then this was in June, and the other like the 2-3 days that the entire floods happened, these were caused by flash floods, as they are as later on the reports have come out, and studies have also taken place. So such flash floods they cause destruction of property around the river, the banks. Then over here we see the image to your left hand side is the after effect of the Amphan cyclone that occurred in 2020. In like it hit the coast of it hit the areas in Odisha, and also in uh, Odisha and West Bengal. So you can see this is again damage to properties that we can see here. Now the image to the right is in January, after quite a few days after the 2004 Indian Ocean earthquake had hit near Sumatra and Andaman Islands. So you can see that the damages that were there, it's not very easy and it's not very quick to recover from. Okay, so this extensive damage is very very hard hitting to the economy at places. So that is why we have to understand how natural hazards occur, what are the possible effects that can happen around that place, and how we can mitigate the effects, how we can prepare ourselves better to kind of handle such events. Now right now at such age, we really need to be very responsive to such events when they occur. Okay, and that will only happen if we are well prepared and planned for the effects that can happen before they happen. And usually in areas which are generally very much prone to such natural hazards. So how do we prepare for it? So first thing we go into is hazard assessment. So where scientists study natural hazards, and they try to determine the characteristics of different hazards like earthquakes, volcanoes, and tsunamis, cyclones, floods. So and this will then this only kind of concentrates on understanding the location, the timing of the different hazardous processes, whether it has been a recurring event or it has happened once in a while, and then also the severity of the hazard that is happening, like how severely does it affect the areas around that site, and the magnitude of past events that have happened before, and also try to predict the possible severity of it happening in the future. So these kind of information is, clubbed together, interpreted, and then the relevant organizations and officials, can make a proper warning system, or preparedness document, and then it can be circulated among the population that is staying in such, disaster prone areas. So that would be the hazard assessment, that is based on the assessing the properties of the natural hazard that we are concerned about. Next is risk assessment. So risk assessment will incorporate information that we derive from the hazard assessment, but it will also club, the probable effects that we will be seeing, happening to the people, to properties, and how it will affect the economic, life of that place. So that would be location of infrastructures, and type of infrastructures, how many are more susceptible to damage due to any of the natural hazards that are caused, that are happening over there. Then potential for the exposure due to physical effects of hazard, and how vulnerable the community over there is to fraud, to such disasters, and then how how possible it is, the possibility of the event turning from the hazard to a disaster. So along with these risk, that is associated with a disaster, and the hazard assessment, so together it will be it is done in the terms of risk assessment. Now with the hazard assessment and the risk assessment, we try to predict the probability of an event happening. So in that, it can be predicted through certain, daily observations that are taking place. Like suppose there are seismic locations, okay, so they kind of record the even the smallest seismic events that are happening every day, and understanding their trend, and understanding the intervals that these events are occurring on. So they can they can try to predict the how close we are to that event, to that hazard converting into a disaster, or that hazard actually taking place and becoming a larger event. And next, there is one more part of how we respond to natural hazards is forecasting. It is like prediction of, and it is again used synonymously, but a forecast is a short term. Like suppose we can forecast an event if it is going to happen within 3 days. Okay, so prediction can happen for a long term event that will happen. Suppose, like if we consider Himalayas as one of the examples. So for seeing the past occurrences of earthquakes that have happened, in and around the areas of Himalayas, we can predict, suppose it will happen after 10 years or 5 years. This is an example, okay? So that would be a prediction, but forecasting was mostly, short term kind of events. So why learning about natural hazards, and then understanding how to cope with the effects of it is necessary? You can see in this picture, in this the comparison picture, the picture to your left is, as I had even shown before, it was it's from Indonesia, and it was due to the 2004 Indian Ocean earthquake. So you can see the devastation that has been caused over here. And now when you see in 2014, this area is redeveloped, and sometimes when you're redeveloping such areas, and if it is a region which constantly face such disasters, then the civil engineers have to take precautions while redeveloping and reconstructing the property over there, so that it can cope the damages that can happen for any future event. So that is why knowing about natural hazards, learning about them, assessing them, and understanding how to minimize the risks caused by such hazards is important in terms of redevelopment or rehabilitation of after a disaster has struck. So as per this map, where levels of exposure of different countries to natural hazards is given, we can see that India is very highly prone to natural disasters. Okay, so and it is not just earthquakes. In a way, different parts of India is vulnerable to different kind of natural hazards. We will see in the upcoming slides. So this is just an example, that no matter where you are in India, any there is a kind of natural hazard that can if impact the life of the people over there. So the first natural hazard that we'll be talking about is the landslides. Okay, so as you can see in the map, the hilly areas, okay, are pretty much, they are prone to landslides. Like over here, you can see the yellow over here, that is parts of Himalayas, and then you have moderate to moderately high. Then even in northeastern states, you see that these are actually hilly areas. Okay, so these are also very prone to landslides. Then you see the pink, linear kind of areas over here. These are actually the Konkan areas, okay, the Western Ghats. So these are again susceptible to landslides. So with that, picture, we can say that mostly it's in the hilly areas, hilly regions, hilly terrain, and especially mountain chains. Okay, and that would be around 15% of Indian landmass, which is affected by landslides. So these are some of the examples of the examples of landslides that have taken place in the history of India, and we can see even Kedarnath landslide is there. So floods, okay, when floods are being caused, it can cause a landslide. Okay, so Kedarnath landslide that is mentioned over there is one of the effects of the floods that were caused over there. So landslides can occur with can occur as an effect, as an after effect of another natural hazard. Next we come to tsunami. So tsunami is caused by earthquakes or seismic activities, or volcanic eruptions on ground of oceans, and there are some volcanoes that are present in the middle of the sea or ocean. So such, and when they erupt violently, they cause huge waves to travel towards the coast and cause damage to the coastlines, and they are like massive tidal waves. And they are very very dangerous, disastrous, and it's very difficult to cope up with this with cope up from such tsunami uh, disasters. So one of the recent that we have is that happened in 2004, which it happened off coast of Sumatra, and it was the magnitude was around 9.1. So it was a huge earthquake that happened, took place, and it affected most of the areas and even far off areas, with the tidal waves. And India was very very hard hit. The southern India, the coastlines were very very hard hit due to this tsunami, and there are some other tsunamis that are mentioned over here. So when we talk about the Sumatra and Andaman tsunami, so there were two different kind of faults that were uh, along which the displacement took place, which caused such a huge magnitude earthquake. So as you can see that this area is kind of a reverse fault, that is called a thrust fault, and this happened within the suppose this entire thing was one tectonic plate. You can see over here, sorry, yeah, so you can see over here the red lines over on the image to the right. Okay, so the earthquake, the the epicenter was marked over here. Okay, and the intraplate thrust happened. Suppose this entire thing was one plate. Okay, so the thrust happened within this plate, and the strike slip fault happened, along the plate boundary. So this is called a decoupled faulting. That is, you have two different types of faults happening, close by to each other, and the magnitude, the high magnitude that was, observed for this earthquake was due to this. Now we come to floods. So India is highly vulnerable to floods, and that is also because we have, such huge river basins, and we have multiple river basins. And in the image that you can see on your right, the magenta parts that are, marked right along the river courses. Okay, the rivers are flowing through this pathways, and all the areas around the river course is actually very susceptible to flooding. We also see that the flooding is very common in the deltaic regions, that is, where the rivers are meeting the say Bay of Bengal or Arabian Sea. So these areas are also very susceptible to flooding. So, and floods are a recurrent phenomena. It is a very natural process that happens, but because the population increase and the the increase in infrastructures and poor urban planning, so the the effects of such recurrent floods is actually getting worse and worse every year. So there is an increased concern because of the damages that are happening, and the damages, the trend is also increasing because of that. So, and also again, floods are also, they can be caused due to another natural hazards, like for example cyclones, cloudbursts, cyclonic circulations. These are, they cause flash floods. Now the flash flood that we were talking about in terms of, Kedarnath, so that was a flash flood, and that was caused due to a cloudburst that happened. So that is why, and India, as I said before also, India is very highly vulnerable, and so we need to understand how, the floods can be mitigated, and how the constructions that are done, can actually withstand the effects that are caused due to floods. These are some of the very, disastrous floods that have happened in the past few years in India. The Uttarakhand, as usual, it's very much talked about. It was a very huge disaster that had taken place, and Bihar is very much, very it is every year it is affected by the floods. And also Assam, the Brahmaputra floods that are mentioned over here. Assam is a state that is very vulnerable to flooding, and a lot of northeastern states are, usually affected by floods every year during the monsoon season. The image shown over here is actually of Kosi River. Kosi River is one of the major, uh, the major area where the, the floods are caused, and it's also responsible for majority of the floods that are caused in Bihar. So you can see that the blue lines over here, there are, years marked next to it. So these years are actually they actually mention the position of the river Kosi. Okay, the path or the river Kosi has been taking. Okay, so with years you can see that the river course changes its position. Okay, now this is kind of also related to the the geological processes that are happening in Himalayas, which, kind of affect the river courses, the river course that Kosi takes, and the change that happens in the course of the Kosi. So this is why we see, sudden floods, flash floods that happen due to the river Kosi in Bihar. Next we talk about the cyclones. So India is pretty much every year we hear of a cyclone hitting usually the coastline that is surrounding the Bay of Bengal. Now, these cyclones are caused due to the atmospheric disturbances, around a low pressure area that is created, on the water body. So, and cyclones are usually, they are accompanied by violent storms and, heavy rainfall. And the storms are so violent, the gusts of winds are so violent that we have seen images of, trees getting uprooted. And, they travel pretty far distances and then they are thrown off. So, these are some of the characteristics of cyclones. And we have two different kind of cyclones, that is extratropical and tropical. Tropical is temperate cyclones, so they happen at higher latitudes than when compared to India. Okay, so they actually happen in the temperate region, that is mid latitudes, mid to high latitudes. So those are extratropical cyclones. And in India, class cyclones are classified, severe, very severe in that terms by strength of associated winds, storm surges, and the rainfall that is accompanied by with the cyclones. So, cyclones are termed, different with different names based on where they are occurring. Over here, we can see that typhoons, occur in like the West Pacific. Then you have hurricanes that are happening, the northern part of the Atlantic and also the eastern Pacific area, northern part of it. Then in India, we can see that cyclones are, that are happening in the Indian Ocean and also, some part of the western coastline of Africa over here. And so the cyclonic, the terminology of cyclone continues from the eastern coast of South America all the way, till the barrication that is shown here. So these are some of the terminologies that we have: typhoons, hurricanes, tornadoes, and willies and tropical cyclones, as per the location where cyclonic disturbances are happening. Over here in the map, we can see that winds and cyclone, the zones where they are very highly damage risk zone. So you have the coastline is the eastern coastline is mainly very much at risk of severe cyclones, and the central parts are not very badly affected, but they are sometimes, when the landfall does not happen right at the coastal areas, it sometimes moves. And sometimes even if it does not happen due to the landfall, the weather conditions in central India, they are kind of affected due to such cyclonic disturbances. So these are some of the major cyclones that have taken that have occurred in the past few years, which have caused a lot of destruction. The one of the recent ones is the Tauktae that emerged from Arabian Sea, which is which does not happen very often. Most of the cyclones actually generate in the Bay of Bengal, but Tauktae that happened in 2021 originated from Arabian Sea. Then you also have Maha also, it approached Gujarat. So there are few cyclones which emerge in Arabian Sea. We can see even Vayu was one of those which emerged in Arabian Sea. Now we come to one of the most important hazard, that is the earthquakes. And earthquakes, as I have mentioned before, due to earthquakes you can have landslides, you can have flash floods. So earthquakes are very important when it comes to understanding natural hazards. And with respect to India, you can see that India is classified, categorized into different zones. Okay, so zone 5 is the very high risk zone. Okay, to intensity, when we are talking, we I had explained the difference between magnitude and intensity in the previous class. So you can see that The very high risk zones are, somewhat constrained in the northeastern parts and the Himalayan parts. Obviously, Nepal is over here, and Himalayas are, extending that side, and they are pretty, high risk zones. So you can see, and then the orange is high risk. Okay, so as we come down from the mountainous regions to the plains, okay, we see that the risk zone decreases in its category. Okay, and these are some of the seismic regions and the number of earthquakes of, high magnitude. You can see that northeast India has, on an average it has much more severe magnitude earthquakes. Okay, and the return periods are, less than 4 months, so that is very recurrent events of earthquakes happen in the northeast Indian region. And over here we can see that 59% of the landmass of India is prone to earthquakes. So that is, more than half of the Indian landmass. So which makes understanding earthquakes and minimizing the risk caused due to earthquakes is very important in Indian context. So these are, this is a list of 10 worst earthquakes that have been experienced by India till date. Now we talk about earthquake recurrence. Okay, so to predict, if another possible earthquake event will be caused or not, we try to understand the, recurrence interval of an earthquake. In the figure shown over here, suppose this was one of the earthquakes that have happened. Okay, we have the record of this. Now the next earthquake happens at this time. Okay, so this T1 is the time interval between the first earthquake and the second earthquake. Okay, so now you plot along the stress and time over here. Suppose you know the, critical failure criterion that has, that we measure, with respect to the parameters of the fault that is causing the earthquake. Okay, the stress mentioned over here. So we see that between two earthquake events, the stress keeps rising. Okay, this is interseismic stress. Okay, so it keeps rising, and when the stress reaches a failure, criterion. Okay, this failure criterion corresponds to the strength of the rock, along the fault that is present. Okay, so suppose it's a very, the strength of the rock is high. Okay, so it can accommodate much more stress, okay, before it fails and causes an earthquake along the fault. So we see that between two seismic events the stress is increasing, then we have a seismic event and the stress drops. Okay, to an amount of stress that is residual. Okay, so this residual remains almost constant over here. So, and suppose sometimes at places the stress does not drop totally towards the, the residual stress amount of the, area. So suppose that that is not a big seismic event. Maybe the magnitude was lower and the entire, stress has not been released. So again the stress will start increasing. So these times, okay, T1, T2, T3, these are the recurrence intervals between two, consecutive seismic events. And understanding these and interpreting these is helpful when we are trying to minimize the risk caused due to the earthquakes. So how do we minimize the risk, or how do we, kind of do the hazard assessment that I had talked about before with respect to earthquake hazards? So you first estimate the seismic risk that is, associated with that area. So you have a compilation of hazard maps, that, like, the seismic hazard map that we have for India, that has been categorized. Then seismic gaps. Seismic gaps means the gaps between two seismic events that have, been recorded and had taken place. You have deformation maps to understand, the kind of deformation that is happening. the kind of traces that we can find due to such deformations that are taking place. Then you have microquake monitoring to understand the kind of intensity and magnitude of the seismic events. Then we try to classify the faults, okay, and maximum moment magnitude, we had talked about this in the last class, how moment magnitude is calculated. And the slip rate is the rate of change of slip along the faults, along the fault planes that are above associated with the concerned earthquake area. Using these, then we kind of try to predict the seismic gap. Okay, suppose we have three seismic gaps, we have information about it, so we try to understand after how long can the next earthquake can happen. Then the microquake swarms, micro cracks that are forming due to the earthquake events that are taking place. Then you have change in seismic velocity due to the micro cracks that are forming. Suppose there is a different kind of a deposition that is happening. Then you have some non-seismic indications. So this is sometimes we have heard the animals start behaving differently. There is changes in the level of groundwater and the chemistry, electrical conductivity. These are non-seismic indications. These are not always associated with the earthquakes, but sometimes these are kind of pre-indicators of kind of seismic activity if it is going to take place. So now we try to understand the types of stresses that are taking place, which is causing these deformations and the related movements. Okay, so you have confining stress where the rock is not actually moving; it is experiencing uniform stress along all directions, horizontal, vertical. Okay, and compression is suppose the one of the directions is the maximum stress direction. Okay, so it will get and it is kind of pushing the rock towards inwards, say. Okay, so that would be compression. Then you have rocks being pulled apart by tension. Okay, so along one of the directions the tensional stresses are maximum, so you will the rock will break apart over there. And then you have shear. Okay, so due to shear we see transform plates when we have seen the plates are brushing again past each other, so that is due to the shear directing in one direction and the other direction. So over here when we are talking about confining stress, okay, so suppose okay, so confining stress we can see is, okay, you have the stress along all the directions are kind of equal. Okay, sigma 1 is equals to sigma 2 is equals to sigma 3. Okay, suppose this is your sigma 1. Okay, this is sigma 2 and this is sigma 3. This is again sigma 1. Okay, and this is sigma 2. So sigma 2 and sigma 3 are horizontal. Okay, and sigma 1 is vertical. All of these are equal, so it's a confining stress. Now suppose your sigma 2 is much more than sigma is, sorry, not equal, it is say greater. Okay, so your sigma 2 is greater than sigma 1 and sigma 3. Okay, so if there is a rock block, okay, so it will get compressed. So this is your compressive strength. Then when we talk about extension, okay, suppose we are just talking in terms of sigma 2 right now. Okay, so the sigma 2 is again greater than sigma 1, but it is in the tensional, they are pulling away from each other. So suppose this is a rock block, so you will have extension along the sigma 2 direction. Then you have shear stress. Now shear stress is suppose the you have one of the forces acting in this direction and the other force acting in this direction. Okay, so it is being pulled apart, pulling. Okay, but there is the forces are equal and you will see a bend. Okay, so this is a shear stress. So we had learnt even in the previous lecture about faults and elements and everything. So when we are talking about, suppose this fault, okay, so this is a fault plane, okay, where we can see slicken slide. Okay, these kind of indicate the direction of the faults, that is direction of the movement of the rock block. We can see that this rock has moved, okay, this way, and some part of it has also moved this way. So you can see that there is a slight horizontal movement and there is a slight vertical movement of the rock block. Okay, so similar way when we are talking about normal fault. Okay, so normal fault is happening when, suppose we say, the horizontal stress that is acting, okay, is more. Okay, so this will cause a extension, and we see that this is a brittle deformation, and the rock block over here has moved downwards. This is called the hanging wall. Okay, and this is the footwall. So the hanging wall has gone has been displaced downwards along the fault plane. Okay, and this is due to the extensional stresses. Now when we talk about reverse fault, it's the opposite. That means that this is due to the compressive stresses. Okay, now over here again, this is the footwall. Okay, and this is the hanging wall. Why? Because this is a fault plane. The rock block above the fault plane is always called hanging wall, and the one that is below the fault plane is called footwall. Okay, so now we see that the hanging wall has moved on top of the footwall, relatively. So this is a reverse fault, and this happens due to compressive stress. Now when we talk about right lateral and left lateral strike slip, these are due to shear stresses, as explained before, that one of them, they are working against each other in opposite directions, and these slide along the fault plane. Okay, so the movement that we see here is along the strike of the fault plane. If you remember, we had learnt about strike and dip of the planes, bedding plane, fault plane in the previous lecture. So you can first watch that, and then you will understand when I'm talking about the strike of the fault, and the movement is along the strike. And the same way over here. Now why is this right lateral? Because if you observe from here, the right hand block is coming towards you, and when you observe from here, the left hand block is coming towards you. That is why right lateral and left lateral. Now we see that there is a fault. Okay, you can see that the fault is going along this direction. Okay, this is the fault line. Okay, and you can see that there is some displacement over here. So if we kind of take a cross section across this, we will see that it will look something like this. Okay, so this is your fault plane. Okay, this block has moved downwards, this has probably stayed over there only. Okay, and due to the movement, this has gone down. Okay, and this area, okay, this steep kind of plane that we see over here, this is called fault scarp. Okay, this is called a scarp. So this is one of the features of normal fault. Okay, why normal fault? Because the hanging wall has moved down and foot wall is over here. Okay, with respect to the fault plane and with respect to each other. Now when we talk about reverse fault, we see that if we take a cross section, okay, and this is suppose a fault line, okay, along which the displacement has happened. So this has moved like this. Okay, now why do we see a fold over here? Because the compressive stresses that have acted. Okay, so it has been accommodated by a fold. This is not exactly a brittle Brittle deformation, this is kind of like a ductile deformation. Okay, it's not totally, it has not reached that brittle point. So over here we see that this is the hanging wall which has moved upwards, and this is the foot wall that is displaced downwards. Now when we come to Indian context, okay, what are active faults? Okay, faults along which the movements, the deformation is still happening, you know, even right now. So Himalayan region is one of the, you know, very important examples of such active faults. We can see that there are several thrusts. Okay, these are major thrusts. Okay, so this is your main frontal thrust, this is your Jalmukhi thrust, this is your main boundary thrust, this is main central thrust. STDS is the South Tibetan Detachment System, LHC is a Lesser Himalayan Crystalline Basement, okay, and this is the Indian basement, and this is the Tibetan plateau, which is a part of the Eurasian plate. Okay, so we know that due to the collision between Indian and Tibetan plateau, you know, Himalayas have been formed, and these thrusts have taken place. So this is again due to the compressive, as we had talked about. So all the thrust faults that we see here are reverse faults. Okay, so and the displacements along these thrusts are still happening. Okay, this is going on top, this is going below, this is going on top, sorry, this is going on top, and this is, you know, below. So because of, you know, uh, deformation, or because of movements along all these thrust planes, the fault planes, we still we get the seismic activities which lead to earthquakes and then landslides in Himalayan region. Okay, so you can see that these thrusts are actually, you know, dividing different kind of areas within Himalayas. We have sub Himalayas, that is towards the plains, the plain plain areas of India. Then you have lesser Himalayas, then you have higher Himalayas. Okay, one more active fault that is very famously known is the San Andreas Fault. Okay, so we can see that the, you know, this is a okay, this is a subduction zone. Okay, but the San Andreas Fault is actually a transform fault, even because this plate is, you know, it's moving this side. Sorry, sorry. Okay, you can see the movements over here of the different plates. Okay, okay, so over here you see that this plate is moving this side, this plate is moving upwards. Okay, now continuation over here, you see that this plate is moving this side. Okay, this area, this is moving on top. So because it connects over here, okay, because you see that, you know, this is connecting over here, this becomes a transform fault over here. Okay, so this is a subduction zone. Okay, and these are also, you know, different plates that we see. These are fracture zones, these are ridges. Okay, this is where your divergent plate boundaries are. Okay, because it's causing a ridge over here, this is forming a ridge. So you have different kinds of, you know, plate boundaries over here, but San Andreas Fault essentially is a transform fault, and it is still active. Okay, over here as we see that that the plates will be locked with no movement at all as they push against each other, and suddenly the build up strain, you know, the strain that is accumulated due to the, you know, stresses, it will release, you know, every few years. Okay, and the plates will again move, you know, for a few feet or kilometers, and again it will, you know, stop moving for a while. So this is how, you know, learning about active faults and learning about the movements that are happening across these active faults is, you know, it will help us in determining the different earthquakes, and, you know, how to study them, how to assess them, and how we can, you know, try to minimize the risk that is caused. If we never knew that this is an active fault, okay, then we cannot take the precautionary measures around this area, you know, or we cannot apply different methods to, you know, strengthen the construction, strengthen the infrastructure that we are trying to build over here. Okay, so that is why learning about these natural hazards and such areas where natural hazards are predominantly affecting. So that is important for us when it comes to civil engineering and also as earth scientists or geoscientists. So for today, this is all. So hopefully this gave you an idea about a brief idea about natural hazards and how you can why it's important for us to learn and some basics about the different natural hazards that we kind of undertake under consideration to plan our infrastructures later on.